Easily my favorite lesson of this unit is solving radical equations. I like solving because solving means we're trying to figure out what is x equal to. Alright, and that should bring back memories of grade 7, grade 8, grade 9, grade 10, where you're just solving for an unknown. Okay, where this is going to be different is there will be a radical with a variable. Okay, so what do we do when we have that? Well, to solve, when you have a radical, you're going to square both sides. That gets rid of the radical. Now the only problem with that is that might create what we call an extraneous root. So you're going to have to always check your answer to see if it's okay. So let's look at an example and you'll see what I mean. So I want to solve for x, I want to isolate it. I'm going to square both sides to get rid of the radical. So this is going to give me 5x is equal to 100. Divide by 5, x equals 20. And I would like you to put your answers in parentheses like that. So it looks good. Let's check it. The root of 5 times 20, does that equal 10? Well, does the root of 100 equal 10? Yes, it does. So this is good. This question is done. It's done correct. Alright, let's try this one. Now you notice that in this one back here, I put brackets and I squared both sides. You don't need to do that if you think you can do this in your head. Like if you want to visualize, square this, I get 5x. Square this, I get 100. That's fine. You don't have to write that in. Divide by 5, x equals 20. Okay, let's see how that works. So check. So is the root of 5 times 20 equal to negative 10? Is the root of 100 equal to negative 10? No, it is not. This tells me I'm rejecting this and I'm going to say there are no roots, no answers, no solutions. Okay? Let's try another one here. Again, I want to isolate the x without the radical, so I could square both sides right off the bat. 3 squared is 9. 4 root x squared is 16x. Now if you're not sure why, let's try this. 4 root x squared is 4 root x times 4 root x. This is 16 root x squared. Okay? Divide by 16. X is 9 over 16, and there's my answer. Let's check. So make sure when you're doing these that you always put in your solution in the original equation. The original equation, not one that you've worked with at all. Okay, so this is 4 times 3/4. And yes, so this is going to be 3 equals 3. So that's good. Okay, let's try this one. You'll see this one's a little different because my radical is not by itself. So what I want to do is get it by itself. Just like when you're isolating an x in algebra, I'm going to add 7 to both sides. So I get 20 is 2 root x plus 1. Next step, you're going to divide both sides by 2. And then if I square both sides, I get 100 equals x plus 1. So x is 99. Check. 13 is 2. 99 plus 1. 13 is 2 times the root of 100 is 10. And yes, 13 equals 13. It's good. Alright, now we'll do a couple with 2 radicals. This usually means collecting like terms, not always, but sometimes. In this case, these are like terms, so I can put them both on one side. So let's take away 4 root x from both sides. So that will give me 3 equals root x plus 1. And then I'll take away 1 from both sides. And then I'll square both sides. And then I'll check. 4 root 4 plus 3, does it equal 5 times root 4 plus 1? Well, this is 8 plus 3, and this is 10 plus 1. Yeah, 11 equals 11. We're good. All right, now, I mentioned before that sometimes you're going to have what's called an extraneous root. So let's look at a couple of questions with extraneous roots. Now, you won't know that when you start the question. You'll just see solve and verify. So I'm looking at this question. I'm going to try to get the radical by itself. So let's take away 5 from both sides. Okay, and right there, as you get good at this, you may notice, wait a second, can a root ever equal a negative number? No, it can't. So you're kind of, maybe you're going to be sold on this and just say, no, this isn't going to work. Let's try it. I'll square both sides now. So 2x is 10, x is 5, and it seems to work. It seems to be okay because I have a solution, but let's check it. Okay, if I check this, what happens? I get the root of, well, this is 9. Okay, you should, right here you should say, wait a second, how can this plus 5 equal 2? How can 3 plus 5 equal 2? It can't. 8 does not equal 2. This is no good. So this means no roots, no solution. Okay? Next one. Well, these radicals are not like terms, so I can't collect them. I can't put them together. But the good news is there's nothing else, so I could just square both sides here. So I get 2x minus 5 equals x minus 7. Algebra gives me x equals negative 2. Okay, so let's check this. The root of 2 times negative 2 minus 5, does that equal the root of negative 2 minus 7? Well, this is negative 9, and this is negative 9. And you're thinking, hey, this is good news. Those are equal. But you can't have a negative in a root. So what does this mean? Well, this is a little bit of a strange one. These are equal. But if you have a negative in there, you have a non-real number. Okay, so what we're going to say here is not that there's no solution. We're going to say that there's no real solution. Okay, the number that we have in here is not real. A negative in the root is actually going to give you what's called the imaginary number. Okay, and let me quickly show you what that looks like. You do not need to know how to do this. But if you have negative root 9 equals negative root 9, the imaginary number is the root of negative 1. So I can write this as 9 times negative 1 and root 9 times negative 1. This gives me 3i and 3i. This says they're equal. But the only way they're equal is if I can use imaginary numbers, which are not real numbers. So that's why we say there is a solution, but it's not a real solution. Okay? When does this happen? This only happens when you have two negative numbers that are equal to each other in the radical. Okay? So that's the end of the unit. Alright, and I have this assigned, but I also want you to go on the My site, and I have a chapter review, and I believe it's called a cumulative review. There are a lot of questions in there. This is great study material. You know, if you don't ever tell me, hey, I need more practice. There's lots of practice. Okay, so let's get ready for your test. It'll be the first one of the year.